Okay, welcome back to another video in this series on design patterns, or more specifically, object-oriented design patterns. And in this video, we are going to talk about observer pattern. And if you haven't watched any other videos in this series, let me just mention that, again, this is a series where we go through design patterns, and I also have another series that's a whiteboard series, right, where I talk in front of a whiteboard, so it's more like a lecture series. So if you think that I'm skipping some of the concept, or if I'm glancing over some of the details in these videos, then I would highly suggest that you go check out that series, because there we talk a bit more, let's say, on a higher level of abstraction. So we look at UML and discuss the ins and outs of these patterns. So sometimes I'm glossing over some of the details. But anyways, I'm just saying, if you think that I'm glossing over some of the details, go check out that series. And also, I mean, maybe go check out that series anyways. Either way, but what we're doing in this series is that we are actually implementing all of these different patterns. So hopefully the same ones that we've gone through in the other series. So what I want to do in this video is actually I want to do three things, and we're probably not going to do all three in this video, so it might turn out to be 2 videos or it might turn out to be 3 videos. But the number one thing I want to do is I want to implement an example which is roughly similar, I mean not exactly similar, but roughly similar to the one that we talked about in the lecture video. So the one regarding weather station, which I also think is originally from the Head First book. I don't think that the Gang of Four book uses that example, but I may be wrong on that. By the way, I mean, I keep mentioning these 2 books, the Gang of Four book, like the original Design Patterns book, and the Head First Design Patterns book. Links to these should be in the description. If you want a book, or if you want a or multiple books on design patterns, I would highly recommend these 2 books. You won't regret the purchasing decision. I mean, these are good books. But anyways, as a side note, but what was I saying? I was saying, yeah, probably that example is from the Head First book, roughly, right? So we're going to roughly do that. That's number 1, right? But again, as we did in the last video, so the last pattern we looked at was strategy pattern. Then we did 2 videos, right? One where it was sort of a more hypothetical example, and then another video where we looked at a more concrete example where I took an example from actual work that I do as a PhD student. And I think we're going to do the same thing here. So we're going to take first that example that we used in the lecture series, the weather station example, and then I'm going to do probably what will be another video, and we're going to look at how observer pattern could actually be used in a real world context. And it seems that you guys thought it was a good idea as well. We discussed a bit in the comments after the last video that we'll take the same simulation example that we discussed in episode 2 of this series, and we'll keep building on that, right? So we'll just add patterns to that problem and see what we can do with these different patterns. So I want to use observer pattern for that, and I actually think it's going to be super suitable. Okay, I'm going to stop talking about this and we'll get into the code in just a short moment, right? But that's number 2 that I want to do, the second thing that I want to do. The third thing that I want to do is that because we are implementing patterns in C#, so this I didn't say, by the way, but I mean, we're implementing the patterns in C#, so a statically typed object-oriented language. And if you're in another statically typed object-oriented language, don't worry too much about it, right? I mean, you'll see the translation, no worries. And if you're in a dynamically typed object-oriented language, also don't worry about it. Just think about it. Like when you're in a dynamically typed object-oriented language, we just simply omit the interfaces and we use duck typing, right? So that's sort of the major difference, but most of the patterns are roughly the same. Not all of them, right? Which we will hopefully talk about, or I will remember to talk about when we get to that point. So for example, the visitor pattern is slightly different. But anyways, that's that about that, right? So sorry, the third thing that I want to do is then that I want to make use of the facilities that already exist in the .NET framework for observer patterns. So not all patterns, right, have this ability to actually be implemented in reusable code, right? Like an actual, like importable code. Many of the patterns are just ideas, right? They're just like we're giving a name to an idea that we tend to redo, that we tend to see a lot of the time in code, right? Like a pattern, right? Like something that keeps reoccurring in code, a common solution to a common problem. But some of these patterns can actually be implemented in reusable code, such as then the observer pattern and such as the iterator pattern, for example. So yeah, I want to dig into that as well, but in order to sort of separate the different things so that we are not confusing the idea of observer pattern with .NET's implementation of observer pattern, let's make these separate things. So yeah, let's just get started and we'll see if we end up with 2 videos or 3 videos. Anyways, okay, I have the Wikipedia page of observer pattern here. Let's actually, before we go any further, let's just read something from this, okay? So the observer pattern is a software design pattern in which an object called a subject maintains a list of its dependents called observers and notifies them automatically of any state changes, usually by calling one of their methods. So yeah, I mean, we could read lots of more stuff, but actually I think we have everything we need to understand observer pattern within this sentence, right? The observer pattern is a software design pattern, blah, 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 in which an object called the subject. Okay, so there's this thing that we call the subject, and the subject maintains a list of its dependents. These dependents are called observers. Okay, so there's a relationship between a subject and observers. And notice singular and plural, right? So there's a relationship between a single subject and multiple observers. So it's a one-to-many relationship. And the subject notifies the observers automatically of any state changes, right? So they're implying of any state changes within the subject, right? So the one thing might change, and whenever it changes, it will notify all of the observers that are observing the subject. And this usually happens by calling one of their methods. I don't know how. What would another way of? Yeah, I guess like emitting something like globally or something like that. I don't know, whatever. Maybe there are other ways of doing it, but definitely the way we are going to look at it is by, as they are saying here, calling one of their methods. And there here refers to the observers, right? So when the subject wants to notify the observer, the subject calls one of the methods on the observers, right? So think about it. It's like subject accepts observers, and these observers all share a common interface. So it knows that it has some particular method that it can call in order to notify them of changes. Yeah. Is there anything else we should say about this? Automatically and any state changes by one of their methods. No, I mean, yeah, I think that makes sense, right? Let's dive down into, let's find the UML diagram. UML, yep. Okay, so, actually, sorry, I should say, I'll stop saying subject because I think this is unnecessarily confusing, because to me it just makes tons more sense, grammatics, whatever. It makes a lot more sense to talk about an observable that's being observed by observers, right? Like, you can see how this sort of, the two words complement each other. You have something that's observable, and then there are observers that observe the observable. And just kind of makes sense, right? Maybe I should also say that 2 things come to mind, right? Like events, which they also mentioned events here, right? Like it is mainly used to implement distributed event handling systems, blah, blah, blah. We don't even really have to, but most modern languages such as C# have built-in event constructs, right? So if you think about that, with the existence of, okay, probably, I'm just going out on a limb here, maybe when you have a problem that could be when you're facing a situation where you could use observer pattern, you could probably also use events, roughly, right? Like they would solve the same kind of problem, because I mean, you'll notice that they are essentially very, very similar. Okay, so what we're doing, UML. Okay, so you have a subject that has a relationship with observers, right? And you can see the star here where they're trying to denote that the subject has a relationship with many observers. Notice that both of these things are probably interfaces, okay? Then, because these are abstractions, right? And then you have concretions down here, and this is a concretion of the subject, and these two are concretions of the observer. I'm just going very quickly because, again, if you want to see this in detail, go back to the other lecture video. So the subject, they only have one implementation here because they only have one implementation, but you could of course have multiple subjects. So actually you could have multiple subjects that can be observed by observers. Doesn't matter. I mean, that's why they have this subject interface, so that you could construct multiple different kinds of specializations of this thing that can be observed. And then we have 3 methods here: attach, detach, and notify, right? So to an observable, you can attach an observer, right? You can add an observer, and you can detach, you can remove an observer, and then you can notify. So you can tell every observer that something has changed, right? And you can see here that they actually show the implementation here where they say for each O in observers, update that observer, or notify that observer of a change, right? And then they have the observer interface here that only simply just says that in order to be an observer, you need to expose a method that I can call in order to tell you that I have in order to tell you that I have changed, right? From the perspective of the observable, right? In order, when you add observers to me, you need to give me a way of telling these observers whenever I have changed, because that's my purpose as an observable, right? And that is through this update method. And then you can see these are the update methods are implemented here down in the observer. Actually, sorry, I said this was these two were interfaces. Probably they mean that this is an interface and this is an abstract class, because notice how attach, detach, and notify are not actually implemented here in the subject. I think for the sake of simplicity, we're just going to do this as interfaces, but surely you could do this as abstract classes. But I think you can probably figure out how to do that so that you won't have to rewrite the attach, detach, and notify logic for every specialization of the subject, or for every specialization of the observable, for every concretion of the abstraction observable. Anyways, way too much talking. Okay, let's get into the code. So I have an empty folder, and let's just open up Vim, and again we're going to keep it simple, so we're just going to smash everything into one file. So we're just going to open a file called program. We're going to say using system, and then we're going to say that we have a class called program, and we have a public static void entry point that we're calling main, right? Console, right, line, and then we're just going to say something like hello world, like we're just doing something silly in order to make sure that we're wired up correctly. By the way, let me also mention that somebody mentioned in the comments of another video that maybe I should check out some of the style guides for C#, and you are absolutely right, and thanks a ton for the link and for the information that you were sharing. Yes, you are absolutely right. I apologize. Just in order to save time for myself, I'm just going forward with writing in whatever style I tend to write in. But clearly, if you are working together with other people, it makes a ton of sense to make sure that you're writing in a harmonious way. I think you're seeing what I'm saying. But anyways, so what I'm saying is that you're right? But I apologize. I just I'll sort of do the quickest thing that comes to mind. Anyways, let's get back to it. Okay, so I'm saving this file, and then I'll map a keystroke in Vim to, what is it, mcs program.cs. So I'm mapping a keystroke to compiling this file, and then I'm mapping another keystroke to running the exe file that will come out as a result, right? So let's just compile this to see that we're all good, and you can see we have no errors, so it seems that we're fine. And then let's run the file that came out, and you can see we have hello world as an output. Okay, so now we're sort of we are wired up correctly, so now we can go. Okay, so what's the goal here? Sorry. Remember, it's a weather station example, right? So we have, let's say we have multiple weather stations. Actually, sorry, we have a single weather station. We have a single weather station, and then we have multiple consumers of weather station data, right? And the weather station produces weather. Actually, let's say. Yeah, let's say produces. I mean, it produces weather data, and specifically, let's say temperature, right? For now, okay, let's stick to temperature. And I'm saying I was a bit confused about produces, because produces isn't really a sensible way of thinking about it. Because if it's a weather station, like physically out in nature, then it would probably, like if it's a sensor, right? Like think it's a thermometer for example, right? In a room, like it's the software representation, or it's the program that's running on the thermometer, let's say. Then produces doesn't really make any sense, because it's not producing weather data, right? It's like it's it's consuming weather data from the environment, or then maybe you would say it observes, but then I don't want to use the word observe because then that will conflict with the word that we want to use in this video, right? Because this thing that we're describing here is not the observer, it's the observable. So it's the thing that can be observed rather than the thing that observes. So I'm going to stick to the word produces. Sorry about that. So yeah, a single weather station that produces weather data. For now, let's just say temperature. Maybe we should say, for example, temperature. And then we have multiple consumers of weather station data, right? So what do these do? Like, let's just make something up. Like one prints, it's like one prints everything to screen. Another one computes, computes the average over time. And yeah, let's stick to these two, right? And then think about it. Yeah, let's stick to these two. And then if we think about something else, let's maybe bring that in. But probably this is going to give us enough code to sort of fill the screen. So so anyways, okay. So you might have already figured this out, but this is of course the observable, and this is the this is a description of observers, of multiple observers, right? So maybe I should actually do this and this. Okay, so this is a description of an observable, and this is a description of multiple observers. Okay, so now we have something like this is where we are going. So let's build this up. So let's not think about the observer pattern, but let's just build the weather stuff, right? So let's say that we have a weather station. What do we want to do? Maybe we want to say it has a, let's say, and I'm just going to keep it simple. We're going to say temperature, actually in so let's just say Celsius, or degrees Celsius is, let's say, we're initializing it. That actually makes no sense. We should initialize it. Yeah, but actually, whatever. Let's initialize it at 0, whatever. So, yeah, apologies for Celsius. I'm, or actually, not apologies, but I mean, I'm from Sweden, so hence we use Celsius. Whatever. Just an example. Maybe I should rather, yeah, let's initialize. Yeah, it doesn't matter. Okay, sorry. I mean, let's not, sorry, I started to think about the whole weather representation problem and all of that stuff, as in like, the example code that we're building. That's not relevant. Okay, I'll forget about making sure that the weather station is appropriately designed, and instead we are simply going to try to focus on observer pattern, right? So let's say that there's a void method called set degrees, and it takes an int, and let's call that d for degrees, and then just say that this dot degree Celsius is equal to d. Okay, so the reason, so if this was a true weather station that actually sort of consumed weather data from, like, again, like if it's an actual thermometer, then maybe this wouldn't be, that maybe we wouldn't have this set degrees. But I mean, we're gonna have this set degrees in order to be able to change it so that like something can happen, right? Because otherwise, what's the point of observing the weather station if it actually never changes, right? So we're going to need, like, we are now, like, looking at this example, we're going to need a way of changing the actual degrees. And yes, okay. So let's say that's the weather station. Actually, maybe what we do is we should say weather station WS is a new weather station. Just instantiate that and maybe say set degrees to 10, and then console write line. Aha, we need a way to get degrees. So maybe I should actually, yeah, okay, so maybe I should use getters and setters, but or whatever, right? It's like int get degrees. Or actually, maybe I would do this. No. Let's actually do this. Let's say something like this. This is the temperature. Let's say we return not temperature, but weather data. So there's a method that returns weather data that's called get. Let's just say get data, right? and that thing can extract all of the current data. So then we say this dot, and then maybe we should just return data, right? We should have like a data variable, or we would construct a new data object here. So does that really matter? No. So let's say return new. Yeah, I mean, never mind. Let's just do it this way. It'll be interesting. Return new weather data where the temperature is degrees Celsius, something like that, right? So then we have a class called weather data. That's essentially like what do people usually call these? It's like data object, value object, right? Where it's like, so I think I have a syntax error somewhere. What am I doing? Oh, sorry, because so I didn't finish this line, so let's just comment that out so we remember that we need to do that. But okay, so public weather data. Actually, we don't need a constructor. No, we need a constructor. Wait, it's so weather. Should I mutate? Should I not mutate? Actually, since it's a value object, so I'm contemplating whether I should do this. Weather data. Data is new weather data, and then just say data dot degrees is. But no, I mean, I should make it immutable, right? Yeah, that makes sense. So let's say, oh my god, okay, we have a public int which is called degrees. It has a public getter but a private setter. And then we have a constructor called weather data. So this is a bit overkill at the moment. That takes an int which is degrees. And then we're going to say this dot degrees is equal to degrees, like that, right? Because then you could actually pass something else in the future, like we could pass humidity and all of that. But actually, I mean, yeah, this is a bit shady. Sorry, I should have thought this through a bit more. It just feels like I'm sort of this just feels like pretty bad design, and I don't really want to do it this way. So actually, I am sorry for doing this, but what we are going to do is that we are going to do this. Weather station is going to have a collection of weather data, and you can push weather data into the weather station. Yep. I'm sorry about changing my mind, but what we are going to do is we are going to do this. Weather data, it has some data. That's a new list of weather data, like so. Sincere apologies. I understand I should make up my mind a bit more before. I thought I had, but apparently I had not. And then do we pass anything in the constructor or not? Should we pass in some weather? Yeah, we maybe don't even need a constructor now. Okay, so then public add, so public void add data. You can pass in some weather data, and then we say this dot data dot add some weather data. Yep. And then you have the weather data class, which is now actually a interface. So let's say, oof, I made this unnecessarily complicated, man. We'll see if this will make sense. I hope now it's very good that we're doing 2 examples, because otherwise this would be massive overkill. Anyway, so let's say that there's a string which is the name of the data, the data point, right? Like that makes sense. And then some int. So yeah, this is a bit funny because then like, is it okay. Design decisions. Okay, I'm gonna drop this now. This is an interesting problem, because now I'm coupling to an int, and this has nothing to do with observer pattern, but I wanted to avoid giving you an example of something that I actually intuitively felt was a poor design choice, which I felt in the first structure. But now I'm also being a bit confused about this one, because now we're coupling to an int, so maybe we should make this like a weather data like over a generic t or something like this. But whatever, I mean, exercise for the reader. If you have some ideas about how we should structure this a bit more elegantly, please do shoot something in the comments. I'm just gonna hard code an int, and we're gonna stick to that for now. But yeah, apologies. Okay, so value, let's say. Okay, maybe this instead of name, this should be key. Name. And yeah, I'm not using strictly key value pairs, but I'm using our own type weather data in case I want to change something further down the line, right? So hence not key value. Okay, now, so the weather station collects weather data, and that's fine, right? And then you can now wait. This is an interface so this is now the value object, right? This is a can I? Oh my god! Oh, I'm so confused. Can I do properties interfaces C#? Can we have properties, or do I actually need to specify get set? Property declaration. Yeah, I can. String name get set, right? So string name get. And I want to have a private set. I don't think I actually can do that. Yeah, this is a bit... Whoo, I've painted myself into a serious corner. Let's just do get set like this and drop it. And again, I'm sorry, maybe you have some ideas about how this design could be excellent. And that would be super cool if you could discuss that. Okay, or share that so we could discuss that. Okay, interface weather data. That means we have a class which is temperature, which implements weather data, and then public temperature. Yeah, but now I'm just being stupid. Then that's not actually, that's not even an interface. I mean, that's just a class where we just say public weather data takes some string, which is the name, and some int, which is the value, and then it sets the name to the, yeah, okay, sorry, value is a keyword, v, val, val, the name to the name, and it sets the value to the val. And then we can actually do that, and then instead of set, we can have private. So now we can actually have private setters, right? Let me maybe line these up. Okay, let me close this. Yeah. My guts. So what I was trying to get at is I was trying to think that maybe weather data should be polymorphic, so that you know, we're sort of protecting ourselves against possible future pieces of weather data. And yeah, maybe what we should have done in that case is that we should have done something like we have a weather data interface, and we don't actually care about how it's produced, right? But we care about the fact that we can get the name, and we care about the fact that we can get its value, something like that. And then we would have some weather, and then this would be temperature, right? And then temperature would have this particular implementation. But okay, so that's probably the more appropriate way of doing it. Whatever, this time I'm going to try to actually drop it. My goodness, this is why my videos become so long. Anyways, weather station. Okay, weather station, weather data. Let me just blindly compile and see where we're at. Okay, 19 has a semicolon error. I don't need this, I don't need that. Compile. iCollection, we're missing the namespace, so system.collections.generic. Let's compile that again. 20 accessor problems, private. Yeah, okay, sorry, because we need to say public in both of these, actually, like that. And then 7 weather station. Actually, I forgot to read the error. Weather station does not contain a definition for set degrees and no extension, blah, blah, blah. Yeah, okay, because we're calling set degrees. Okay, now, all right, because that was from... Oof, okay, because that was from before. Okay, so what we want to do is we want to say WS. So the weather station, maybe instead of WS, I mean, that just makes no, it's difficult to read. Let's say station. So the station dot add data, okay. Whew. This is where I want to get at. New weather data, okay? Temperature, 10. All right. Okay, compile. Yeah, okay, just a semicolon, compile. And that's fine, and let's run that. And of course, yeah, we have no output. But, okay, so we can add data, but now let's say that we need to be able to get data. So should we get there like this? Let's just do this. Print data. So you're gonna see why I did this, or I mean, the point is I didn't want to expose the collection, and I didn't want to have to bother about iterator pattern or anything like this, like copying data or anything like that. So yeah, so let's just make it, and we'll get into that discussion when we get into iterator pattern. But so you'll see why, unless you already know why. But what we want to do is something like this for each weather data in this dot data, and then we just say console write line, and let's just say d dot name plus plus a colon, and then plus d dot value. And maybe, sorry, actually what we should do is we should say console dot write line d dot to string, right, and override the toString method in print data. That would, or sorry, in the weather data. That would make more sense. So now I can't remember how this goes, but like public string override or something like this to string, and then here we can simply just say this dot, return this dot name plus this colon thing plus this dot value, right? So I mean object orientation, right? Instead of, or maybe what is that? Tell don't ask. I'm telling the weather data to give me its string representation rather than inspecting the details of weather data and making a decision on its behalf. Anyways, okay, so print data, that works, maybe it works fine, we'll see. But then we can do station.print data. Let's just try this and see where we're at, right? 20, yeah, we're missing one here. Override, yeah. So I did this wrong. So maybe it's public override, string to string. Yeah, that works fine. Let's run that, and then you can see that we get temperature 10. Such a long way to get to this point, but okay. Hopefully you're still with me. We are gonna get to iterator pattern. Don't worry about it, okay? It's gonna make sense. All right. I was a bit, I mean, here we should have actually done something like, yeah, I mean, we shouldn't. Okay. Sorry, I need to stop thinking about real-world design. We're going to talk more about real-world design when we get to the real-world example, so please forgive me for doing stupid stuff. Of course, the weather station should not interface with the UI here, right? Of course, I should just map over this data and collect to string. But I'm trying to keep the example as absolutely simple as possible, so I don't want to involve link, and I don't want to build up the, okay, but anyways, I mean, what we could do is we could just say str, this empty string, and then just say str plus equals d dot to string, and then return str, which is the same thing as mapping to string over, and okay, let's just do that. So we're going to return this dot data dot what is that in link? It's not, is it map? Do you do map? Sorry, C sharpers, I hardly don't do any C sharp to string. I would guess it's something like this, right? And then you would using maybe system.link, is it something like that? No, link 20 to sorry, like that. Contains no for map. Yeah, so it's not called map. So select maybe. Print data. Oh wait, what was the error? Print a return keyword must not be followed by any expression when method returns. Yeah, okay, sorry, because it was void. So now it should return string. Cannot implicitly convert, because then we need to say to list. Maybe I need to specify a type. Yeah, so to list of string, something like that. No, please work. Cannot implicitly convert type. System collections generic list string to string. Oh, yeah, because I need to join this. Why did I make my life so complicated? Because now we need to reduce over this, and then this is totally unnecessary for the example. Yeah, this is, I'm sorry, functional programming. I've spent way too much time there. Let's just do this because it's quick, and let's not think about link and yeah, some other time. So we are missing a colon there. Return keyword must, yeah, okay, so then we're back to this problem where this should return strings. I was undoing backwards, and then we just use this for each stuff. And of course, you should absolutely every time use map and reduce rather than what I'm doing here, right? If you're, this is a side note, right? But if you're ever in that discussion with someone who's arguing that this is more clear, I can't remember who made this argument, but there's this great argument where somebody says that, but the thing is that with this, or with a for loop, for example, you actually have more logic. There's actually more code, so there are more things that potentially could go wrong, right? Because there's this adding here, right, which isn't necessarily, yeah, but that would be in the reduction as well. So maybe in for each there isn't necessarily more logic, but in a for there's definitely more logic, and there's this temporary variable here. And yeah, I mean in a for you definitely have more logic, so you definitely have more things that could go wrong. But anyways, always of course do the functional equivalent of this, like map and reduce. But in order to not confuse the contents of this video, we should be talking about observer pattern. In order to not in order to not focus on the wrong details, and in order to not confuse you if you are not familiar with map and reduce, for example. Anyways, let's drop that. Okay, that works. Yeah, that compiles. Let's run that. That actually runs. Okay, so now we can say console write line, and then we just print the data. Compiles, and then we run that, and then we get temperature 10. Okay, super duper good. Actually, here I should add plus /r/n because we want to have a new line. I guess, yeah, that works. Okay, so then let's add some more data, right? And instead of having 10 here, let's say 20 and 30. Actually, it's too much. So 11, 12, 13, 14, right? So it's like the temperature steadily rising over this period of time, right? We compile that, that compiles, and then we can run that, and you can see that we get this temperature out. Now, okay, so this is our code. Let's say this is the code that we're going to work with, which only took us 37 minutes to get to. My God, I'm sorry. Next time I'll be faster. Promise. Well, at least for the next pattern, right? But anyways. Okay. Why would we need observer pattern here? Well, this thing, print data, right? That's one of the potential observers, the thing that prints all of the data. Okay. The other one, that was one we wrote here, prints everything to screen. The other one computes the average over time. Now, if you don't have observer pattern, you would have to sort of set up a timer or something like this and just occasionally ask the weather station for its data and see if it has changed. But with observer pattern, it's super simple, because then it's like a stream or like events that you can simply listen for the events, right? Or you can consume the stream. They're sort of very, very similar ideas. So what we want to get at is we want to say something like this. We want to say station. So I'm going to actually, let's remove that line. Let's remove the printing line, right? I'm going to say station dot add observer. And actually, I'm just going to say observe, right? No, add observer, because maybe we want to remove it. Add observer, and then I'm going to add an observer, which I'm going to call, let's say, printer. Okay, printer. And then we're going to say station.add observer, and we're going to add the averager, maybe? Okay. Computer? Yeah, this makes no sense. Let's say averager, the thing that computes the average, okay? And yeah, so we're going to need those two variables. So the printer is going to be of type observer. Or actually, let's say weather data observer. So let's be super specific. Printer is going to be a new, and then we're just going to say, I mean, the concretion would be a printer maybe, okay? And actually, maybe we should call it a weather data printer, okay? And then maybe we have a weather data, again, same types, weather data observer, that's the averager. And that's going to be a new weather data. Actually, let's call that a consumer or something like that, right? Like, not consumer, let's say aggregator, something like that. So it's like, it's aggregating in some kind of sense. Aggregator, okay. So create 2 observers and then add the observers, right? Of course, this doesn't compile if I try to compile this, right? Clearly, I mean, because we're missing a lot of stuff. We don't have the, let's say, interface. Let's begin with this, weather data observer. We don't have the interface weather data observer, right? We don't, right? We're pretending we have this sort of abstraction here, but we don't actually have that. And we don't even know what that's going to contain yet, right? So let's just leave it at that. And then we don't have the class weather data printer, okay? And again, we don't know what that's going to do. And then we don't have the class weather data aggregator, but let's create that. Okay, so now we have those. Does that compile? Of course not, right? Because, actually, sorry, let's read the error message. Cannot implicitly convert weather data printer to weather data observer, right? Because weather data printer is not a weather data observer. So then we need to say, okay, well, it implements the interface weather data observer. And same thing here, weather data observer, okay? And actually maybe weather data observer. Let me put the I here to denote that it's an interface to sort of follow, at least a bit follow the sort of C# convention. Okay, so that should bring us a bit further, right? Type or namespace, weather data observer could not be found at line 14. Here, weather data observer. Yeah, sorry, okay. I forgot to put the I here, so we went backwards. But okay, let's compile that again now. So 18, weather station does not contain a definition for add observer, and no extension method add observer of type weather station could be found, right? Because here, let's comment this stuff out. No, but, or sorry, pretend, let's say this, let's add a comment. Pretend that new data arrives to the station, right? This is what we're doing here, right? Like we're sending pretend data to the weather station so that we have something to observe. And actually, of course, this needs to happen after we've set up the observables. After we've set up the observer to the observable, or after we've added them to the observable. So, and maybe like just to be exhaustive, let's add a comment here. Create observable weather station. Maybe that's completely self-evident. It's like, this is a comment. Ah, it's a comment. Okay. So weather data printer, weather data aggregator, and weather data observer. And what were we saying? What were we saying? We were saying that add observer is not a method that exists on the weather station. So the weather station now needs to do that. So let's say weather station. We could just add the method, right? But we want to follow this diagram. We want to follow this UML diagram. So notice weather station does not at all look like the subject here. Does not at all look like the observable. So now we want to make it look like the observable. And so let's say it's an observable, right? Or sorry, it's an observable. And then let's create the interface observable, right? Whoa, what am I doing? Caps lock? Yes, caps lock always messes me up in Vim. I should remove caps lock. Anyways, so yeah, observable, and we can see here. I mean, observable. We know what that should do. It should have a method that says attach, but we're just gonna call that add observer, and it's gonna take something of type weather data observer obs, or let's call it O. And actually, of course, sorry, if add observer takes something of the specific type weather data observer, then this shouldn't be an observable. It should be an weather data observable. Yes, right? And then we have the same thing, but not add, but remove. And then we have maybe notify, maybe not notify. I mean, the question is, do you want to be able to tell the observable to notify all of its observers. I think actually this doesn't really make any sense to have that public, but maybe we should have that public. I don't know. I mean, depends. You tell me, right? Yeah, I mean, let's make that private. Let's not care about that. Let's keep it simple. So add observer and remove observer. Okay. And actually, I mean, I think you can see if we can add observers, then we can remove observers. So let's make this even simpler and just remove observer, right? I mean, you can add stuff and you can remove stuff, and you'll be able to figure out how that works, right? So let me add a comment here to say observer pattern stuff below. Okay. Never put a comment like this in your system, right? But or I mean, maybe, yeah, depends on the scenario. But I'm just doing that to be explicit here. Okay, so now we need, actually, let me compile this just to make that explicit. 39, oh no. So sorry, you remember how I said that C# or .NET actually already have an implementation of observable? That's what happens here. They're saying using the generic type observable T requires a type argument. So they're assuming that we're using their observable type. So we need to figure out another name, and probably observer. Yeah, or actually, sorry, I mean, it's not a problem because we changed our name to weather data observable. Weather data observable. Yes. Okay, so then we should have the error that we were looking for. The weather station does not contain a definition for add observer. This we've talked about. Weather station does not contain a definition for blah blah blah. Weather station does not implement interface member add observer, right? That's what we were looking for, because here now we need to add public void add observer, which is going to take some weather data observer. Let's call that O for observer. And we're going to save the observer here, but let's just not add the implementation, because, I mean, if you think about it now, we should be able to compile, right? Yeah, because then that solves this error, but these are essentially the same error, but on a non-interface level. Or actually, I mean, they're on an interface level, but this is strictly weather station's relationship with its contract iWeather data observable, whereas these things are the fact that program is trying to send the message add observer to weather station, but weather station does not accept such a message as per its contract. Okay, so how do we save the observer? Well, we just do something like this. I mean, observers add O, right? So then we need a list of observers here. So we have an I collection of what do we call the observers? Oh, we haven't built that class, did we? iWeather data. Of course, we've built that. iWeather data observer, observers equals new list of iWeather blah 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 blah. Right. Okay. What a long line. Okay, and then we add that. Yeah. So actually, I'll remove this comment because this is the observer stuff. There's nothing more to it. Actually, there is something more to it. Sorry, let's undo that. Because now we should be able to compile and we should be able to run. Still nothing happens. And yeah, I mean, we've removed the printing here up from the program. So there's a bit of a way to go before we can get back to that point. But now we should do something like void. Sorry, and this is what I was saying, that maybe this should be private. We have a notify method that essentially does this for each iWeather data observer. How can I forget this every time? It's such a strange thing to forget. In this dot observers o dot notify, and we want to notify it of something, right? But we're gonna hang on with that, right? We're gonna I'll fill this in a moment, right? But the question is, what do we notify it about, right? So in the lecture series videos, I had this discussion, and then what we did was that we made a connection here, like this line that they have here, and there would so the observers have a relationship, like the concrete observers have a concrete relationship with the concrete subject. They have dependency on the subject, the concrete subject, which is an odd thing to do because you want to couple to abstractions, not to concretions. And I think some of you guys had made great comments in the comments section saying that, of course, what you could do is just pass the data in the notify, or sorry, maybe this should be update, right? Or new data or whatever. But let's actually call it notify in that end as well. You could just pass the data to that method so that you would know what data it needs to consume, right? Actually, let's call it update, right? So yeah, maybe let's add that data at once. So what I would do here is I would do something like this. So whenever there's new data, right? This is the way we're going to use notify. We're going to say this.notify, but what do we actually want to notify it about? Or what do we actually want to notify all of the observers about? Well, what we want to do is we want to notify them about the new weather data that just came in, right? Whatever's passed in here. So we add the data to the weather station's own collection of data, and then we notify the observers about this new data that has come in, okay? And then so then this notify method should then, of course, take some weather data. Yep. WD. This should maybe call be data. And yeah, instead of weather data, maybe I should have called it weather data points. So we could have called this point and then like the collection points or something like this. So the naming is a bit funny. And then if I would actually work on this system, I would, of course, work a bit more on the naming to get things more clear. And it's beginning to look a bit messy. But anyways, we would pass the weather data to every one of the observers. Let me remove these to make it a bit more clean. Okay, so right, so when we notify when we want to notify the observers about some particular weather data that have just arrived, then we loop through all of the observers in the list or in the collection list.observers, and then we call update on all of them to sort of notify them of this new piece of data, and we simply pass this new piece of data to them, okay? Of course, now we're gonna have some interface problems because we haven't really, like we're pretending that we have contracts that we don't have. So 58, so iWeather data observer does not contain a definition for update, right? So we're pretending now it has the method update. So it's iWeather data observer, right? So we're going back up. Okay, so this interface was empty, right? We just knew that we need to have this interface, but we don't know necessarily what it needs to do. Or actually, I mean, we could have known because this is the observer, and if we look at the UML diagram here, we can see, of course, that it should have the update method, right? But now we know that it needs to have a void method that is, or we don't need to know that it's void, but let's say that it's void, right? It's called update, and it takes some argument, which is what, right? It takes some argument, which is of type weather data, because that's the thing that we're going to pass it. That's the new piece of data that's incoming to the observer. Okay, so let's save that. Let's compile again just to see where we have more errors. Okay, so 30, weather data printer does not implement interface member update, right? Of course, right? Because we were saying weather data printer is of, or implements the interface iWeather data observer. Weather data aggregator implements the interface iWeather data observer, but none of them have the update method. So of course, then they need to have public void methods that are called update and take some weather data. Let's call it WD. And we don't actually know what the implementation of this is yet. So let's just leave that. Let's compile, and buzzing. Now this actually compiles, right? We can still run it and we get nothing. But, you know, I mean, at least some progress, eh? So what would the weather data printer do? Well, previously, when we printed here in the program, right, we were just printing the data one line by one line, right, by asking the weather station to print data here, right? We implemented print data. Now, what if we just here simply say console write line the weather data's name plus colon space, and then the weather data's, was it value? I think so, yeah. What if we just do that, right? What happens? Can I compile? I can compile. Can I run? I can run, right? And now we actually get that same output again. But now we've moved this printing logic away from the weather data, from the weather station, sorry. We've removed it from the weather station, and we've said that this idea of consuming the data and doing something with this data that's coming in. Sorry, I'm mixing the word data and data. I don't even know which one is more, whatever. so the idea of consuming that and doing something with that data, that shouldn't necessarily be a responsibility of the weather station, right? So now we can remove this. We remove the print data method, right? Because why should it have to be able to print the data? It's just saying that, well, I'm an observable, so if you want to be able to print all of the data throughout all of my history as a weather station, then fine, sure. I mean, just observe me. Whoops. Just observe me and collect the data, and then you can print it any way you like, right? So notice how we're now, like, we're eagerly printing whenever there's new information coming in, right? We're just like, when we hit this line, we just print it. When we hit this line, we just print it. When we hit this line, we just print it. It's not like we're collecting them. Like, think about it. Whenever we do add data here, then we're immediately printing it. So like, maybe this makes it more obvious. Right line, whoop, adding more data. Right, let's do that, and then let's put that here and here and here and here, right? So before we add more data, we say that we're gonna add more data, okay? And you can see then that we can add more data, or adding more data, and then we get the output, and then adding more data, and then we get the output. So my point is that it's not like we're just collecting all of the data and then printing in the end. I mean, we could of course have done that. So we could of course have said that the weather data printer isn't maybe a printer, it's like a collector, right? So it just collects all of the weather data, and then we have a let's say print data here that sort of does this for each thing that we had before, where it's like or maybe it returns a string, right? So it's like all data or something like this, right? So it's like it's returning a string representation of all of the data that it's ever seen. So it's just something that collects all of the data. And actually, if we think about it that way, it's even more interesting, right? Because then maybe the weather station doesn't even need to keep track of all of its weather data, right? Because like let's think about it. What if the weather station is working with something like it's taking in new weather data input like every, I don't know, 250th millisecond or something like that. It's going to be tons of data. So maybe it's an unnecessary complication to say that it's going to save all of the data before we actually know that, like, it's a requirement to save all of the data, right? So let's just say that, I mean, fine, I'm just a weather station, but if you want to save all of the data, you can. But the way you do that is by eternally observing me, right? So I'm removing this list of weather data. So now we don't even need to add this weather data. So now we're just saying that the only thing that this weather station does is that it collects weather data. And of course now, I mean, the way we collect weather data is by calling add data here, which is of course very silly. Like, this has nothing to do with observer pattern, right? It has nothing to do with observer pattern, right? It's just like we need to be able to do something sensible within this example. Okay, I'm gonna have to try to wrap this up because we're going super long. But okay, where was I? Yeah, so I was emphasizing that we are adding more data. We are eagerly printing as soon as we are adding more data, but we could of course collect the data and then just print in the end. And I think probably you can figure out how to do that. And if you can't, then try to do it, right? So my point is that what we would want to have as output is that we would want to have, I'm just faking it, right? Like with this implementation that we have here, we would want to have 1, 2, 3, this output, right? Oh, sorry, whether number 10. Wait, did I actually accidentally remove something? What was it saying? The type namespace weather data printer could not be found. Weather data printer. What? Did I accidentally delete it? I am so confusing, man. Weather station. Let me undo backwards. What am I doing, man? Did I? I must have accidentally pressed that. That's pretty silly. So I accidentally deleted the weather data printer. I meant, of course, not to delete the whole thing. I meant, of course, to delete this all data function. Okay. So what I was trying to say is that so with this, let's just make sure that compiles so we don't have, yeah. So with this input, we want to have 1, 2, 3, 4. We want to have this output, right? First we add all the data and then maybe we print all of this stuff. Like that would be a way of, that would be an observer that collects all of the data and then prints it. So exercise for the reader. I mean, if you don't intuitively just say, oh, of course I would just do it like this, then try it out, right? And try to find a way of doing that. Okay. Now, let's build the other observer. I think you're probably like really understanding observer pattern at this point, hopefully, right? But let's just build the other observer so that you can see another way of using this, right? So let's say that we have something like an average. So why did I choose average and not sum? How do you compute a running average? You need to keep track of the sum. So we start from 0, and you need to keep track of n, like the number of items. Do you need to keep track of the sum? Yes, of course. Yes, so, right, because so n starts at 0 as well, right? Because sorry, because the average is the sum over the number of items, right? Or observations, let's say. So maybe we call this yeah, let's actually call it n, whatever. So to compute the new average, average starts at 0 as well, let's say. Makes no sense. I mean, it might start at something else. So whenever we receive a new weather data piece in the weather data aggregator, to compute the new average, we would have to say that this dot average, we're overriding the old one, is this dot sum over this dot n, right? But of course, then we need to update this dot sum. So we update that sum by by adding the data point from the weather data. Weather data dot value, sorry. And now this is an interesting situation because like we might have all kinds of different weather data, and then you might not actually want to add like everything to this particular sum, because I mean it might be temperature and then like I don't know, like humidity, and those things make no sense when you mix them. So maybe this is a visitor pattern situation, probably because we've lost type information that we want to recover. It's not a type checking situation, because no situation is ever a type checking situation. You're probably looking for the visitor pattern if you have a type checking situation. Anyways, or a replace conditional with polymorphism. You're probably looking for that kind of situation. Okay, sorry, that was a side note. Okay, so we update the sum, and we update n by just adding 1, essentially, right? We were saying we have one more observation, and this is the new sum, and then we compute the new average, right? And then we need to be able to return the average. So let's actually make this a public, a public int average. Let's not do that. Public int get average. Yeah, maybe I should just call this average or something like that, but whatever, get average, and then we just say return this .avg. Okay, does that compile? Yes, it compiles. Can we use it? Yes, we can. Okay, so print result of aggregator observer. Right, so let's do that. So we could say no, aggregator dot get, what was it? Yeah, get average, right? And then console write line. So we write that out. Okay. So the name aggregator does not exist in the current context. Why? Because I can't spell. Aggregator, yeah. So aggregator. That's fine. Okay, and then let's line that up, and let's try to compile again. Either the data observer does not contain a definition for get average and no extension method. Okay, so sorry. So I can't treat this as an weather data observer here. I need to treat it. Am I gonna run into troubles here? I'm gonna have to treat it as a weather data aggregator. I might be, no, that's fine. Okay, whew, I thought I was going to run into troubles. So then if we're saying that as a concretion, then maybe I would want to say this as a concretion as well. Weather data printer, let's line these up again, let's compile again, and then let's run, come on. Ooh, and it works, right? Because here then we would say the average is this. So that's the average in the end. Right? Does that work? So let me just console write line, and then let's just print. So the sum is 10 plus 11 plus 12 plus 13 plus 14. divided by 1, 2, 3, 4, 5, 5. Compile, run, 12, right? So the actual average is 12, so presumably that's correct, right? That works, right? And of course, we could have done something like whenever we receive a new data piece, instead of just collecting it. So let's say maybe here we print total or final averages, and then whenever we have a new data piece, we could also just say console write line. I'm just doing this as an example, right? Like, don't do this. Running average plus this dot average. Right? Let's just compile and then run. Then you can see, okay, the new temperature, like we have a new temperature, which is now 10. Okay, the running average is 10 because we only have one data piece. The new temperature is 11, and the running average is still 10. Right? So we don't have decimals. Look, right, because I'm returning I'm saying that the average is an int, right? So maybe we should actually say that it's a double or something like this. Oops, let's line those up. Compile. 50, because here we should return a double. That's more interesting. Why am I doing this? 10, running average 10. Yes, I'm still getting this dot average is this dot sum divided by this dot n. So I'm in 10 plus 11 divided by 2, I'm going to get 10.5. So somewhere I'm sort of throwing this down into, yeah, this is not relevant for this video, so I should just drop it. But somewhere I'm casting this to an int. I'm truncating it. So yeah, C# folks, maybe you could tell me what I'm doing wrong here, but maybe like I should force this computation to be treated or force one of these numbers to be treated as a double, and that would sort of make it yeah, okay, so something like that. So that's actually the same thing as Ruby, but okay, whatever. So now we actually get, so if I force one of these numbers to be a double, or I cast one of these numbers to be a double, which is funny because I just said don't typecast, but primitives are different situations, which is which then makes it evident why primitive obsession is a bad thing, and why we should stay away from, why we should use more complex classes when we have something which truly isn't a primitive, right? So then, because otherwise typecasting with these primitives, for example, isn't safe, right? But that's just one of the problems, right? Like model the domain, model the actual domain of values that you have, right? If every possible, yeah, sorry, this is a different discussion. I have other videos on typecasting and on primitive obsession. So do check them out. I mean, it's a fairly interesting discussion, right? It's like, if you have something like a phone number, then a string isn't a sensible representation for that, for a phone number, because the domain of possible strings, or the set of allowed strings, is not the same as the set of allowed phone numbers. But that's dangerous, right? Because that's why we have type systems. So you should construct a type such that every possible instance of that type is an accurate representation of a phone number, right? It doesn't necessarily have to be somebody's phone number, but on a type level, it's a sensible phone number. It's a phone number. It's a well-formatted phone number. But this is a different discussion. Do check out those videos. Okay, but yeah, so now we're printing the running average, and then you can see that, okay, we update the temperature to 10. We then have a running average of 10. We update the temperature to 11. We then have a running average of 10.5. We update the temperature to 12. We then have a running average of 11, and so forth and so forth and so forth, right? And then we have a final average of 12. And yeah, I mean, I hope you can see how this this works. Then you could just keep sort of observing into eternity. I'm just adding tons of more data here, right? We compile, it works fine, and then we run, and then you can see, whoa, okay, the final average is 12, right? After all of these updating, all of these data points, right? Let's change one of these like to 140, right? And we have a different number out. So yeah, and hopefully now you can see how this is sort of very similar to the idea of streams and to the idea of events. And now I'm going to wrap this up because it's such a crazy long video. to wrap this up, look at the UML diagram, right? We have the observable, we have the observer. The observer, or the observers observe the observable, and then you have concretions of observables, and you have concretions of observers. And of course, I mean, think about this. We now have a weather station, but the weather station implements the interface where do we have it? iWeather data observable. So we could, of course, create something else, which is iWeather data observable, and have multiple observables, so multiple weather stations. And those could be, so the same observer could observe both of them, or different observers could observe both of them. But of course, since we have that interface, we can, right? So fairly cool pattern, and it's actually gaining a lot of traction with frameworks such as, for example, rx.js or rxjs. Yeah, I mean, never mind. I'm not very familiar with that at all, so maybe I'll try to get familiarized, because I would love to do some videos on that and definitely use it, because it's probably suitable for the functional programming gaming series that I'm running in JavaScript. But yeah, that's one example. And then I mean, frameworks like Ember.js and Angular, they make heavy use of observables to update user interfaces when underlying models change. So that's like a very classic sort of canonical example of observer pattern. But I think probably the future lies somewhere in usage along the lines of RxJS. Okay. Let's now wrap this up. Thanks a ton for watching. If you appreciate this video, hit the thumbs up button, and remember to subscribe so that you won't miss the next video. Let me know if you think this video was too long, but apart from that, stick around and I will see you in the next one. Thanks a ton for watching.